So today's lecture is going to have two videos. The first video is going to be me just talking you through the notes. And then I'm doing a second video using my document camera so that I can draw out a picture that may help you to understand blood types and RH groups a little better. So after you've watched this video, I highly encourage you to go watch the other video. It'll be a little bit shorter that will go through some of the little bit more difficult material, but it will give you a visual representation to kind of help you understand. So we've talked about red blood cells, we've talked about white blood cells, but we've not talked about platelets yet. So platelets are part of our blood sample. Remember, they're only like 1% of our blood sample, but they are not cells. These are fragments or pieces of cells, and their scientific name is a thrombocyte. And you've seen thrombosis in your vocabulary, and you may have heard of thrombocytes for those of you who watch Grey's Anatomy and things like that. You may have some prior knowledge, but now we're going to talk a little bit about what they do. So the whole point of a platelet is that it helps with blood clotting. When we have a cut or an injury, we obviously need to stop the loss of blood. And so to do that, we use these fragments, platelets, to clot that blood for us because we don't need to lose any more of our volume. So what they do is they basically stick to an area where there's damage. Think of it as kind of like you have a hole in a boat and you make some kind of plug or seal over that hole to keep water from coming into the boat. But in this case, we're trying to keep blood from leaving our boat. So platelets, because they're not cells, because they're fragments, they have no nucleus, they don't last very long. They quickly degenerate. So it's a temporary fix to some type of, injury. Now, when we stop bleeding, it is a series of phases that basically cause our blood to change phases and to allow us to stop bleeding. And we call that hemostasis. So here are our phases. Now, remember that hemostasis is a positive feedback mechanism. If you remember back to the very beginning in Unit 1, I told you that we have negative feedback, which is where we move in the opposite direction of the stimulus. And then we have positive feedback where we move in the same direction as that stimulus. So this is a positive feedback mechanism, but when it starts, it's actually negative. The first thing that happens is immediately our body goes into what's known as a vascular spasm. The area that has been damaged, there is an immediate response to constrict blood vessels, and that tells us to stop sending so much blood to the area that has the breach, which makes sense. If you have a hole somewhere, you don't want to send more of your blood. The problem is vasoconstriction, or that constriction of the blood vessels. That's not good because we want more platelets to get there, because the more platelets that we get there, the quicker that we can plug that breach and we can stop bleeding. So our body goes through a positive feedback mechanism to dilate those blood vessels, to increase the number of platelets that go rushing to the site, and then that builds this plug around that breach. Another thing that happens, and this is a very intense multi-step process that requires at least 30 different things coming in and out of it to make it happen, but our blood actually thickens. It turns to almost like a gel in that area, and we call that coagulation. By our blood becoming thicker in that area, it slows down, obviously, how much blood can leak out. So it's just this step, vascular spasms to constrict the blood vessels, but then we're going to go through a positive feedback to create a platelet plug. And then finally, the blood turns thicker in that area through coagulation. Now, there are some things that can happen, homeostatic imbalances, where something could interfere with how your body clots. And we would call these bleeding disorders. It's just basically where you have abnormal bleeding because something happens and you can't go through hemostasis like you need to. So the first one is known as thrombocytopenia. Thrombocytopenia is a condition where you just don't have enough platelets. If you're watching your shows, the medical shows, you'll hear them say, you know, we need platelets or packed platelets because they actually have units of just platelets to give to individuals who are having trouble stopping bleeding during a surgery or after an accident. What happens with thrombocytopenia, though, is that you have a reduced number of platelets, and because of that, your blood vessels just will start bleeding spontaneously all throughout the body. Little things, just moving around can cause you to form what's known as petechia. They're like these little small purple blotches. A lot of times we'd say, oh, I burst a blood vessel in that area. It's just like a little starburst that you see under the skin. And that's a tiny little hemorrhage. But these would happen all over. And usually what causes thrombocytopenia is something is affecting your bone marrow. It's either suppressing it or it's destroying it so that it can't do what it's supposed to. So to help someone with thrombocytopenia, they do blood transfusions to replace blood that's been lost. And then on top of it, they will give platelet transfusions as well. Another one is known as hemophilia. Now, hemophilia, you've studied in biology. This was a bleeding disorder that kind of ran rampant through the royal family because we know that in the royal family there was a lot of kin folks that were married off to one another. And when you lessen your gene pool, then that means genetic disorders are more likely to show up. And if you remember, hemophilia kind of ran through the British royal family. As a matter of fact, I think you had a pedigree of the royal family in your biology workbook that you worked in 9th and 10th grade. But anyway, so hemophilia is a sex-linked genetic disorder. So that means that you usually see it in males because it's more likely on males because males have one X chromosome, whereas women have two. And so females can be a carrier. They can have it, but it's just not as common as you see in males. And so what happens is you lack the clotting mechanisms that you need in your blood. You're lacking clotting factors. And so the smallest little cut, the smallest little scrape, the slightest little bump or bruise causes prolonged bleeding in that area. So if you bump your arm, you will bleed out under the skin in enormous quantities. Cutting yourself, shaving will bleed and bleed and bleed and bleed. So what happens with hemophilia is they have to have transfusions. So they go in for transfusions quite often to replace blood that's been lost. And then in some cases, if they can catch it before you've lost too much blood, they'll just do what's known as an injection of clotting factors. So basically they give you a shot of what your body is deficient or deficient in so that way you can stop the bleeding. So since we talked about bleeding disorders, I think it's a good spot to talk a little bit about transfusions of whole blood. So some of you tried to give blood or gave blood at our last blood drive. Some of you have maybe given blood or tried to give blood previously at other blood drives. And what you gave is known as whole blood for the most part. Some of y'all did give double reds or things like that. But for the most part, we walk in and we give 1 unit, 1 pint of whole blood. And whole blood just means it has everything in it. They don't spin anything out. They don't spin anything down. They don't siphon anything off. They don't put anything back. They just take that blood sample like we talked at the very beginning of this unit. So our body has things that it does to try to minimize the effects of blood loss. Like, for instance, the areas that are damaged, we try to reduce the blood flow there by going through coagulation and things like that. But on top of it, we will also step up the production of red blood cells. Unfortunately, some people bleed too much and those mechanisms don't work. And so that's where your blood donations come into play. So when you give blood, a whole blood unit, your blood can be used for an individual who's an accident, who has maybe a genetic disorder like sickle cell or hemophilia. It may be used for someone who has to have surgery, but your blood is going to an individual who is in need of blood. You never know, one day you may be an individual who is in need of blood. So if we lose anywhere between 15 to 30%, I know that's a pretty broad range, but that's because some people can tolerate things a little better than others. We know that because when people give blood, we'll have, 100 people give blood and 90 people will give it fine, and then we may have 10 people that pass out. And so some people can't lose blood volume as easily as other people. But anywhere between 15 and 30%, you're going to tell that that person's losing blood because they're going to become very pale. They usually come kind of weak, cold, and they're just tired feeling. After or any more than 30%, now we've reached a point where this is dangerous because this individual is probably going into circulatory shock, and that could cause kidney failure and could eventually cause heart failure. And so that could be potentially fatal. So in those cases, when you've reached that 30% plus, a whole blood transfusion is pretty routine. So the way that we determine who gets whose blood is we go by what's known as the human blood groups. And so we have 4 blood types, really 8 blood types. And we're going to talk about how we get those blood types. And this is when we finish this video, you're going to go and watch the other video so that you can understand this a little bit better, because this can get a little muddled. So people have different blood types. And if you get a blood type from an incompatible blood type, then it could kill you. Our body has an immune system that protects us from unknown entities. So if I was O blood and someone gave me A blood, my body would not handle that well because they would see these antigens that are found on the surface of the blood as a foreigner. And so what happens is my body will attack those blood cells. So the presence or absence of the antigens is what allows us to classify our blood types. So we go by what's known as the ABO blood groups. ABO is based on whether or not you have these antigens or agglutinogens, type A or type B. And this comes from your genetics, your inheritance. So if you have A antigens, you are type A. If you have B antigens, you are type B. If you have A and B antigens, you are type AB. And if you don't have any antigens, you are O. So O blood is the most common, and it has neither of the antigens. AB is the least prevalent of the blood types. And determining whether or not you are A, B, or A or B is based on whether or not those antigens are present on your cells. Now, everyone always asks, well, hold on, I know I'm A, or I know I'm B, or I know I'm O, but I'm positive, I'm negative. What does that mean? Well, positive and negative comes from what's known as the RH factor, and that causes us to jump from 4 blood types to 8 blood types, because you can be A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, O negative. Okay, so if you are a positive blood type like myself, that means that I carry the RH antigen. So I have no A, no B, but I do have RH on my blood cells. So therefore, I am O positive. So what does that mean? For the most part, it's not a big deal, okay? If you go in the hospital and you have to have a blood transfusion, the first time you can have a blood transfusion with any compatible ABO type. So let's just say that I go in the hospital and I'm O negative, okay? So they come in and they say, okay, Miss Wharton Mary, we're going to give you a unit of blood. You are O negative, but we only have O positive in the hospital. they could give me that unit of O positive and I would be fine. Okay. But what happens is that positive RH would come in my body and my body would say, I don't know who you are. You're a little sketchy. So I'm just going to keep my eye out for you. And if you show up back here again, we're going to take you out. So fast forward a few years down the road, and I end up back in the hospital and I need a second blood transfusion. And they would come in and say, Miss Fortenberry, you are O negative. We only have O positive. We can't give you O positive because you got that last time. Because this time, if they give me the positive, my body sees the RH as a foreign invader and it will attack and rupture all of my red blood cells. And this is called hemolysis, and that could be deadly. Now, it obviously is a problem with blood transfusions, but it also can be a problem with women who are pregnant. Women who are RH negative have an additional problem because if you are negative and you are pregnant with a positive child, that is like a foreign invader as well. So, first time, it's not a big deal. Your body will just say, okay, this is a positive. We don't know you. We're going to keep an eye on you. Don't you show up again. But the second time could lead to you or miscarrying your child, because what happens is the body attacks the red blood cells of the baby, and then that would cause a miscarriage. So women who go to the doctor and are pregnant, as soon as they find out you're pregnant, they of course check your blood type. And if you are a negative, you are immediately signed up to have what's known as RhoGAM. This is a serum that basically masks the RH so that you can carry a baby to term. I have friends who are RH negative and they've had healthy children. So just because you may have a negative blood type does not mean that it's, you can't have children. It just means you have to do one more additional step. So this finishes the first part of our Unit 6, the blood. So I'm going to suggest, before going on to the next section, which is the heart, that you go to watch the other video where I kind of explain blood typing and RH a little better so you can understand and have a little visual, and then you can go on to your next lecture. If you have any questions, please let me know, and I'll talk to you later.